in previous class, we have discussed biaxial electron pair repulsion theory main point, and according to this theory, the VSEPRT, the lone pair repulsion is greater than lone pair bond pair repulsion, which is greater than bond pair repulsion. This theory tells the geometry as well as the shape of molecule. This theory explains the geometry as well as the shape of molecule. And the shape of molecule depends upon number of bond pairs and lone pairs. Number of bond pairs and lone pairs. For example, if you have the first one example, which is BeCl2. In this, the central atom is beryllium and the atomic number is 4 and electronic configuration 1s2, 2s2 at ground state, and at excited state it will be 1s2, 2s1, 2p1. So it becomes the divalent. So in this, the bond pairs are how many bond pairs? 2 bond pairs. And how many lone pairs? There is no any lone pair, just because we will consider only the valence shell, not the inner shells. So bond pair 2 and lone pair 0. When this happens, when there is no any lone pair and only bond pairs are present in quantity of 2, then the shape of molecule, according to this theory, linear, and bond angle becomes 180. Bond angle becomes 180 and order of repulsion becomes bond pair to bond pair. Only order of repulsion is bond pair to bond pair. And to complete the molecule, 2 chlorine atoms share their electron. To complete octet and form bond. And form sigma bond. How? Like this. This is beryllium with 2 bond pairs. And now in chlorine, the valence shell contains the 7 electrons, which will be surrounded by each atom in this pattern. Now this beryllium is chlorine and again chlorine. So this is whenever 2 bond pair and there is no any lone pair is present, the bond angle should be 180 degree and shape of molecule only and only diagonal and the linear shape. And in this, the bond pair repulsion is present. What type of repulsion is present? Only the bond pair and bond pair. But the second example is BCl3 or BF3. In this, the central atom is boron, atomic number is 5, electronic configuration is 1s2, 2s2, 2p1. But at excited state, according to the Hund's rule, 1s2, 2s1, 2px1, 2py1, and 2pz0. So by this arrangement of electron, there are only 3 bond pairs. And how many lone pairs? 0. The bond angle is 120. Whenever 3 bond pair and there is no any lone pair, then the bond angle is 120 and shape of molecule become trigonal. But the order of repulsion is what type of order of repulsion? Only bond pair repulsion. Only bond pair repulsion. So for this, if the BCl3 boron trichloride or BF3 boron trifluoride, if fluorine is present, then it is 9, 1s2, 2s2, 2p5. So 3 chlorine atoms share their electrons. Share their electrons to form sigma bond. So shape of molecule 1, 2, 3 and arrangement of fluorine is like this. Is it clear? And shape of molecule becomes trigonal like this. Is it clear? Hashir and Alize. Is it clear?
Yes.
Both of you?
Ma'am,
Yes.
ma'am, how do we identify a lone pair before making the structure? Like a
Yes.
bond pair are. So how do we identify a lone pair from this?
In boron and beryllium, the valence shell is second shell. And this second shell, in the L shell, how many electrons are present? Only 3. So these 3 electrons must repel each other. In beryllium, the valence shell contains 2 electrons. And these 2 electrons must repel each other. And this is 1s2. 1s2 means the first shell. And we are talking about the valence shell, which is the second one. That's how we can easily identify it. But yes, there are some other examples. Now you tell, Alize, if the molecule is CH4 and the central atom is carbon and atomic number is 6, electronic configuration is 1s2, 2s2, 2p2. And at excited state, what it becomes? 1s2, 2s1, 2px1, 2py1, 2pz1. Yes, Elise, you tell how many bond pairs are present?
3.
1, 2, 3, 4. The bond pair is always unpaired. Unpaired means only singly occupied. And lone pair means paired, but in the valence shell, not in the separated shells. So bond pairs are 4 and lone pairs are 0. So shape of molecule become good, tetrahedral. And bond angle become 109.5. Just because this is tetrahedral and there is no any lone pair is present, 0 lone pair. So how many hydrogen atoms? 4 hydrogen atoms. Share their electron to form carbon hydrogen sigma bond. One, two, three, four. 1, 2, 3, 4. And this structure can be drawn like this. 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen. And it forms what kind of bond? This is tetrahedral. Yes, Elise and Harshil, send me thumbs up sign for this. Good. Next one is ammonia and water. Nitrogen, central atom, which is 7. Electronic configuration 1s2, 2s2, 2p3. Elise, just listen carefully. It's for you. Oxygen is 8. Now electronic configuration 1s2, 2s2, 2p4. In S2, 2s2, 2 electron, and in P, singly occupied electron. In S2 electrons, and in P, 1, 2, 3, and 4. So, how many bond pairs are present in this, Elise, for ammonia? How many bond pairs? And how we recognize the bond pairs? The bond pairs will be the singly occupied or unpaired. So how many bond pairs?
5.
This one is 1, 2, 3. How many bond pairs? How many bond pairs? 3. And Hashir, how many lone pairs?
5. 1.
1. For oxygen. Yes. How many bond pairs for oxygen?
2.
2. And Aliza, how many lone pairs in this for oxygen? One and 2.
2.
2. If bond pair is 3 and lone pair is 1, so order of repulsion is this. There are 3 types of repulsion. Sorry, 2 types of repulsion. Lone pair to bond pair. Which is greater than bond pair to bond pair. And whenever this kind of the repulsive force are present, then shape of molecule, yes, becomes pyramidal. Why? Just because of the one lone pair. And bond angle becomes 107.5. Why? Just listen. In nitrogen, 1 lone pair and 3 bond pairs are present. This lone pair repel the bond pairs and each bond pair repel each other. This is the arrangement for the central atom. Now 1 hydrogen, 2 hydrogen and 3 hydrogen is present to make the bond. But the shape of molecule shrink as compared to the tetrahedral and becomes the pyramidal, as well as the bond angle also shrink from 109.5 to 107.5. Then again, in oxygen, the order of repulsion. The order of repulsion is lone pair to lone pair repulsion, which is greater lone pair to bond pair repulsion, which is greater than bond pair to bond pair repulsion. And in this, how oxygen atom is arranged, this is oxygen. This is one lone pair. This is second one lone pair, which is just opposite to each other. This is one bond pair and this is next one bond pair, which is just opposite of each other. Now two hydrogen atom combines here, and due to the strong forces of repulsion between lone pair to lone pair, the bond angle again shrank and reduces from 107.5 to 104.5. So bond angle becomes 104.5, while the shape of molecule becomes, it may be named as bent or it may be named as angular. So that means that is very simple, and there's a key which is given in your book and as well as in the notes, from which you can easily identify it. For example, in which the two bond pairs are present, linear shape. If two bond pairs are present, then linear and 180. If three bond pairs are present only, then trigonal, which is 120. If four bond pairs are present, it will be tetrahedral and 109.5. And next, if one lone pair and three bond pairs are present, the pyramidal, and bond angle is 107.5. If there will be two bond pair and two lone pair, then the shape of molecule become bent and the angle reduces from 107.5 to 104.5. Yes, Alize and Hashir, is it clear for you?
Yes.
Yes, ma'am.
And you have to learn some other example. If I will ask that what kind of the shape will be here for AlCl3? Yes. What kind of the shape will be here according to the VSEPRT? Just predict.
It would be trigonal.
It will be trigonal. No, what kind of this? Pyramidal. How you identify? Yes. Phosphorus has the 15 and electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. And in S, 2 electrons, and in P, 1, 2. Am I writing the correct one or the wrong one?
It's 16.
Phosphorus is 15.
Yes, sir.
So is this the electronic configuration for the phosphorus is right or wrong? Yes, 3p3. So in 3s2 and 3p3 means 1, 2, 3, and which is just like similar to the nitrogen. So for this, you have to identify the shape. What kind of shape is this? CCl4. How you identify tetrahedral? 4 bond pairs. For carbon, there are 4 bond pairs according to the 1s2, 2s2, 2p2. Yes, Aliza, you tell. In H2S, what kind of the shape will be here? Yes, Elise.
Madam, linear.
How it is linear? Sulfur is 16. 1s2, 2s2, 2p6, 3s2, 3p4. Am I right? In S, 2 electron, and in P, 1, 2, 3, and this one is 4. Yes, which kind of the, yes, this will be bent. And how we identified two lone pairs and two bond pairs. Ashur, is this clear? Alisa, is this clear?
Yes, ma'am.
Okay, now we are moving towards the next theory, which is known as the molecular orbital theory. This molecular orbital theory is MOT, which is shortly known as, but this according to this MOT, atomic orbitals overlap to form a new orbital called as molecular orbital. When two atomic orbitals overlap with each other, for example, this is S and this is S, then these S will overlap with each other, and this way will be two types, constructive and destructive. If this overlapping is taking place constructively and destructively, then two kinds of the molecular orbital will be formed. But these molecular orbitals are polycentric. Polycentric means which have more than one nucleus. Which has more than one nucleus. And the atomic orbitals are monocentric. Monocentric. And monocentric means which have the only one nucleus. So if there are the molecular orbitals are of two types. Bonding molecular orbital and anti-bonding molecular orbital. The bonding molecular orbital is represented by sigma, and anti-bonding molecular orbital is represented by the sigma style. This bonding molecular orbital is formed by the constructive way, and they are the low density in terms of electron. And bonding molecular orbitals have low energy. What is known as low energy molecular orbitals. But anti-bonding molecular orbitals overlaps with destructive way. It has high density. Okay, high density and low density means it can be said to as in bonding molecular orbital, electron want to stay. And in anti-bonding molecular orbital, electron don't want to go there or stay there. So due to the high energy, the low density of electron will be there. So the high density electrons, high density means electrons want to stay there at the lower energy. And at low density means electrons don't move to there as electrons remain in the lower energy level. It is just like this. For example, hydrogen molecule. Hydrogen is H1, this is H1. This is 1s1, this is 1s1. This is S, this is S. Okay? When they overlap constructively, so they overlap with each other, but by the overlapping, so it will be like this. This is the constructive way. And there is the only one nucleus and there is the only one nucleus. But after the overlapping, there is no any boundary wall in between. And what is this? This is the energy level. When these electrons don't want to go at high energy level, just listen carefully. They want to stay there, okay? But it splits like this. When they overlap with each other, then it will be the S. And how we represent like this? This is one hydrogen. This is another hydrogen. When they overlap with each other, it forms the molecular orbit. And electron stays there. But here, it remains empty. And how we calculate the bond order? How we calculate the bond order here? Bonding electrons or bond pairs minus non-bonding electrons and divided by 2. So how we calculate here? How many electrons for the bond formation? 2. For the hydrogen molecule, the bond pair and lone pair. 2. These are the 2. And at there is no any electron. It will remain the empty orbital. So 2 minus 0 divided by 2. So the bond order is 0. Bond order is 0 for the hydrogen molecule. Yes, Myra. How?
Ma'am, it would be 1.
Good. Only one student recognized this. 2 minus 0 equals to 2. 2 divided by 2 equals to 1. And bond order is 1. Good. So only bond order means only one bond will be formed. And how the one bond will be formed, which is H and H molecule. Okay. In this, the H and H molecule.